All right, Honors Stats. This is chapter 10.3. It's dealing with different binomial trials. I'll be asking you two different things to do, two different concepts. Number one is hypothesis testing for P1 and P2, and then confidence interval for the P1 and P2. So in this video, I'm going to give you two really good examples of both concepts. I didn't make either of these real-world situations because of the data that's given, and that's all you need is the data. So, for one binomial experiment, 85 binomial trials produced 59 successes. For a second independent binomial experiment, there was 112 binomial trials, and it produced 81 successes. We're going to do our hypothesis testing at a 5% level of significance. And we're going to test the claim that the probabilities of success for the two binomial experiments differ. Now, you're going to see the test statistic for all of these problems is Z. So differ, we should know exactly what is going to be done. It's going to be a two-tail test. So I put these exactly how the test is. What I did is, or the quiz. I made up the quiz and I kind of put these particular problems mirror of what I'm going to ask you. So the first thing, everyone, is called the pooled probability of success. It's denoted by P bar. P bar is both of the R's added together divided by both of the N's added together. So our R's are our successes. So we have a 59 and an 81. And N is the total number. We have the 85 and the 112. 85, 112, 59, and 81. This gives me 140 over 197. And if you read the directions, I asked for 3 decimal places, so 0.711. Even though I don't ask you for it, you will need something else. You're going to be needing Q pooled as well, which is 1 minus P pooled. So Q pooled, Q bar, is equal to 1 minus 0.711. So Q bar, everyone, is 0.289. We'll need that a little bit later when we find our test statistic. Since we are hypothesis testing, the next two things we're going to do is state our hypotheses. H naught, our null hypothesis, is always going to be P1 is equal to P2. Our alternate hypothesis, P1 has to come first, P2 has to come second, and we go back and look at the problem if it's greater, less, or different or change, and since it is differ, this is not equal to. There are your hypotheses. Now notice in the third question, I asked you to find the test statistic, and I actually gave you a hint. I wrote both P hats 3 decimal places. So in order for us to find our test statistic Z, you have to find two things first. Individual P1 hat and individual P2 hat. P1 is these two numbers. It's the 59 over the 85. That was the original. And then the second one is the 81 over the 112. So this is not your pooled. The pooled is added the R's divided by the added of the N's. This is R1 over N1, 59 over 85, and R2 over N2, 81 over 112. 3 decimal places yields 694 and 723. Now your test statistic is Z. I'm going to first write the formula. The formula is P1 hat take away P2 hat over the square root of P pooled P bar Q bar over N1 plus P bar Q bar over N2. Okay, so take a look at that formula. And understand you actually have all of these numbers right now. Here's the P bar, here's the Q bar, here's the P hat 1, P hat 2, this is N1, and this is N2. Okay, so I erased everything. Let's now put our pieces in. This is our 0.694, that's our P1 hat, take away 0.723. This is going to be over a big old square root. Remember, it is P bar, which is 0.711, times the 289, which is Q bar, over the first N, which is 85, plus the same two numbers, the 711.289, I forgot the 9 on the first one, 289. There we go, better, 0.289. And then there's what, a 112, okay? Now, this is what's different. Guys, I want you to do this in 2 steps. Please, please, please do it in 2 steps. The reason I'm asking you to do it in 2 steps is we have already rounded twice. So it's okay to round to 3 decimal places. So we're going to subtract these 2 numbers and get negative 0.029. Now, I want you not to plug this whole thing, just to plug the radical in your calculator. Go ahead and do it to 3 decimal places, 0.065. So, ladies and gentlemen, I do not, and I repeat, I do not want you to plug this all in your calculator at one time. Please do it in separate pieces. It has to be done in the second problem. That's why I want it to be done in this first problem. 2 separate things. Squiggle, squiggle, negative 0.45. That, ladies and gentlemen, is your Z. So now, next question says, draw and label a normal curve. So it's going to be your job to draw a normal curve. Where does negative 0.45 appear? About right here. Now you have to go back to the hypothesis. The hypothesis, the alternate, that is a not equal to. So you should know this is a 2-tail. So not only will you have a negative 0.45, you'll have a positive 0.45. Your P value will be this piece and this piece. Okay, so it's going to be both. So our job is to look up on our chart, our Z-score chart, negative 0.45. Now, we've done it many times, and when you do so, you're going to get 0.3264. That means this is 3264 as well. That's all I want for this part. Draw and label. Now, in section E, it says find the p-value in relation to the level of significance. This is where you will write the word p-value. What do I do with the 3264 and the 3264? Add them together and get 0.6528. That is no doubt greater than the 0.05, which was our level of significance given in our problem. If it's greater than, our conclusion is fail to reject H not. And our interpret, ladies and gentlemen, if I come back up here and I find the sentence that has the word differ in it, this whole thing right here is what you're going to repeat. But since it's fail to reject, is it going to differ or not differ? Not differ. So we're going to throw the word not in. So, very simply, our interpret is going to be the probabilities of success for the two binomial experiments do not differ. Do not differ, not differs, do not differ. So while I'm videoing, I'll come up here and I'll show you the words I wrote. The probabilities of success for the two binomial experiment do not differ. Okay, so it's the exact same words in the problem. So let me shorten this up here so we can see everything. So in our hypothesis testing, the first thing you're going to do is find P pooled and also Q pooled. You're going to state your two hypotheses. In order to find your test statistic, you have to find P1 hat and P2 hat to 3 decimal places. Your Z, we wrote the formula down, it's P1 hat, P2 hat, over the square root of P bar, Q bar over N1 plus P bar, Q bar over N2. Please do this as separate. Do the numerator and denominator separately into 2 decimals, 2 3 decimal numbers, and then divide. You should know that this is 2 decimal places because it's a Z-score. Then you're going to draw a standard normal curve and you're going to label it with however many sections, if it's a right tail, a left tail, or a two tail. You're going to make my statement of a p-value what it is in comparison to the level of significance. You're either going to reject H0 or fail to reject H0. Remember, if this is less than, you're simply going to reject H0. And everybody, the interpretive results, either they're going to have the word not, if it's fail to reject, or the exact same words I showed you in the problem if it's a reject H0. Okay. That, ladies and gentlemen, is binomial probability hypothesis testing of more than one probability. Okay, ladies and gentlemen, this is the second type of problem that we'll have, second type of problem that we're going to have in chapter 10.3, and it's dealing with a confidence interval. You can see the question is all the way down here. Find a confidence interval, okay? So in order to find a confidence interval, we have a few things that we have to find first. And here we go. So question. Consider 2 independent binomial experiments. The first one has 401 trials and 156 successes. So while I'm reading, I might as well say, since that's the first one, we're going to find P1 hat. That is the 156 divided by the 401. Directions say 3 decimal places, so 0.389. What I'm not asking for, but you will need, is Q1 hat, which is 1 minus P hat, which is 1 minus 0.389, which is 0.389, which is 0.611. So P hat, Q hat from sample 1. In the second one experiment, there are 523 trials and 167 successes. So this is P2 hat, which is the 167 over 523, which yields 0.319. Obviously, we have to find Q2 hat, which is 0.681. So the first thing we need in order to find a confidence interval are those 4 values. Now, you're going to need question D to help you with C. But I wanted to get question C out of the way first because of the formula. Let me show you. Your margin of error, which is denoted by the letter E, is equal to z of c, which is the critical value of z, times the square root of p1 hat times q1 hat over n1 plus p2 hat times q2 hat over n2. Now, normally, you will know z of c. If it's 90%, you should memorize 1.645. If it's 95%, you should memorize 1.96. If it is 98%, you memorize 2.33. And if it's 99%, you remember 2 point what? 58. All right, notice I have an 88.7, so I made it a little more difficult, okay? Okay, so make sure you round to 3 decimal places. We already rounded this guy to 3, we rounded him to 3. This comes from a rounded answer, this comes from a rounded answer. So make sure we round, plug that whole thing into your calculator, and round to 3 decimal places. So what piece do we still need? We need z of c. Normally this would be easy. We would just write one of those numbers. But we have a little bit of work to do. So here we go. In order to get our z of c, this question says, what is the critical value for 88.7% confidence? Use a normal curve to help. So this is the process that will give it to us every time. Draw your normal curve. Always put 2 lines symmetrical and turn 88.7 into a decimal, 0.8870. You're going to take 1 minus 8870, and whatever that answer is going to divide by 2. That will yield an 0565. That means this piece over here is 0565, and this is 0565. If you add those 3 numbers together, it'll become 1. Now, since we're looking for the positive z of c, you are going to take what's less than that. So you will always add those 2 decimals together. You will add the 8870 and the 0565, yielding a 9435. This is the number you have to look up in the body of the chart. So guess what? I have one. So, ladies and gentlemen, our critical value for this problem is 1.585. So if it wasn't smack dead in the middle like this one, you choose the one that's the closest. If it's exactly, then you choose that particular z-score. You'd use the number to the left and the number that's up. You remember, it's 2 decimal places. So now, everybody, we're ready to finish this guy up. 1.585, 1.585. When we multiply that together, again, 3 decimal places, this yields 0.051. That, ladies and gentlemen, is your margin of error. Okay? The other question won't have that middle one. So remember, the entire margin of error, everybody, consists of z of c times the sigma of our particular proportion. The sigma is this big old square root, and the z of c is either coming from a memorization of 90, 95, 90, 95, 98, 99, or one that you have to do. When I give you this quiz, everyone, you're going to have one that's 90, 95, 98, or 99, and the last question on your quiz will be just like what I'm doing right here. You have to find the z of c. And now finishing up our confidence interval should be very straightforward. The formula is P1 hat take away P2 hat minus the E we just found. Our proportion is going to be in between that P1 hat minus our P2 hat plus the E we just found. So remember, this was the 389 take away the 319. Remember your original P hat 1 and 2. So I subtract that and I get 07. I get 07. We're going to subtract the 051 and we're going to add the 051. 0.019 are P1 take away P2 and 0.121. And you are done. You have found the confidence interval. So again, let's make this a little small. Let's go in green this time. I'm going to give you R1, N1, R2, N2. Your job is to find P bar 1, or P hat 1 and P hat 2. Q hat 1 and Q hat 2. In order to find the margin of error, we're going to take a z-score, a critical value of z that you either have to find or memorize. And then the standard deviation gets multiplied to it. You're going to go 3 decimal places, 3 decimal places, 3 decimal places. And then everybody, your confidence interval, you're going to subtract your P1 hat and your P2 hat, and you're going to add and subtract the margin of error that you just found, leaving you a confidence interval. In this case, an 88.7% confidence interval. And that is 10.3. We're looking for 94.35. And if you look, it falls right here. But let me pinch this open real big for you so you guys can see. If this is 94.35, you have to figure out which one he's closer to. He's 0.006 away from 94.29, and he's 0.006 away from 94.41. So where's he at? Smack dead in the middle. So it's your job to take these two numbers and average them. This is 1.58, and the other one is 1.59. So smack dead in between is 1.58 what? 1.585. So this is the hardest critical value you could ever find.